This one says to factor completely, and I can tell right away that there's a common x in common with all three terms. So I might first think to factor out an x, but if I did that, let me show you what it would look like. If we took an x out, we'd still have a negative x squared minus 4x minus 4 on the inside as my leftovers. And when I factor trinomials, this x squared trinomial here that's left over, I usually want my leading coefficient to be a positive one, not a negative one. So that tells me instead of factoring out an x, I'm going to factor out a negative x. Or negative x is the same thing as a negative 1x. And when I do that, look what I'll have left over instead. I'll have a positive x squared plus 4x plus 4. And you can check that at this stage by distributing back through, making sure you would get back to what you had started with. So negative x times positive x squared would give me the negative x cubed that I started with. This negative x times the positive 4x would give me the negative 4x squared that I started with. And again, negative x times positive 4 would give me the negative 4x. So that tells me that I have factored correctly here. And now look what's left over. Inside here, I have a trinomial with my leading coefficient as a 1, which is nice because then it'll factor hopefully into two sets of parentheses. This one has a negative x still out. Don't forget the negative x is still on the outside. But this trinomial then can factor into two sets of parentheses, x and x, plus 2, plus 2. You could check that by foiling this through. This is called a perfect square trinomial actually, so it factors into x plus 2 times itself. So since it's x plus 2 times itself, I can just rewrite it as negative x, again because of that negative x that I took out from the beginning, times x plus 2 to the second power, because when you times a factor by itself, we can rewrite it to the second power. And so this would be my final factored answer.